stats in your IA if you're doing a stat IA. The first thing I would do is go into stat and click edit. You're going to put information into list 1 and list 2. Ideally, you should have 40 bits of information in list 1 and 40 bits of information in list 2. Now, technically, in the exam, you're going to say you've done it on the calculator. You'll put a screenshot from your calculator, or maybe you'll put a screenshot from my calculator by using the app on my computer. However, fun story is that you can use the results on Google Sheets, and Google Sheets will do it for you much quicker and much more accurately because you can type them in quicker probably. So you can check your answer on Google Sheets and on the calculator. On Google Sheets here, I took this list of numbers and I typed in the 1, 2, 3, 4, 5, 6, 7 bits of data for X and for Y. Remember, you're supposed to do about 40. Now, on the computer, it actually calculates Pearson's for you. To use Excel, all you have to do is you have to type equals, then you type Pearson, then you select the Y values. My Y values are in C, so I type equals Pearson, then I select the Y value, so I just select them using my mouse, which are in column C, C2 to C8. Then I put a comma, and then I select the X values. You always do your X values first, and then, so you always do your Y values first, then your X values. It will say that when you type it. It will say Pearson equals, and then you're supposed to put Y and then X. And then it's given my Pearson here as a 0.5. You've got to analyse what Pearson means. So we've talked about the fact that 1 is completely positive correlation and -1 is completely negative. So what does 0.57 mean? It's not really strong positive correlation, but it's still a positive correlation. Now, if you were to do that on your calculator to check your answer, you've put it into the list. We're going to return to stat. We're going to go to calc, and because there's 2 variables, we're going to type 2 variable statistics. You could do that, or the best thing to do is linear regression, which is linear regression AX plus B. You press enter. X list is list 1, Y list is list 2. You're going to explain these steps in your investigation. Now, this is the really important bit here. Y equals AX plus B, R squared equals R. So again, this has given us the R value. I would check you've got this on Google Sheets. In the actual IA, you don't need to write the fact you did it on Google Sheets. You can, but you're not supposed to include irrelevant information. So the calculator's better. It looks more sophisticated if you've done it on the calculator. So let me just paste this. And we can see that we've got Pearson is 0.5, and we've got our A minus and our B. So we've got our B is minus 7.1453, and our slope, which is 3.9. Now I'm going to talk to you about how you can do this on Excel, which is the intercept and the slope. So the intercept on Excel, what you're going to do is you're going to write equals intercept, really easy. Again, with Excel, you always write intercept first, and then you're going to select the Y values and then the X values, and then it's going to give you the intercept. That means if you were to draw a straight line graph where it crosses through the Y-axis. We're then going to do the same with the slope. The slope formula is exactly the same. With the slope formula, we're going to put the Y values first and then the X values equals slope, select the Y values and the X values. Now, there's a couple of important things I'd like you to do, and this is how you can start getting sort of 12, 13, 14 marks rather than just 10 marks. What you need to do is you need to analyse the lists one by one. So we're going to go on to calc and we're going to one variable statistic analyse them. So we're going to just analyse list 1. List 1, then we've got all this information. This information could be then used to draw a box plot. So with a box plot, you need the minimum, the quartile 1, the median, quartile 3 and the maximum. If I take these values and then we go on to a box plot generator, Desmos. Desmos is probably not the best one to do because the picture isn't the best. So I'm going to put the box plot here, and I'm going to put the information on this side. Using this information, we want to add a 5-element list. Box plots are to do with 5 elements normally. We're going to change this so it's 5 elements. The smallest number is going to be 1. Quartile 1 is 1. The median is going to be 5. Quartile 3 is 9. And the max is 9. So you then delete everything that's irrelevant, and then we've got 5 elements, and then we're going to see what the box plot looks like. There we go, there is our box plot. And you can talk about what the box plot means. So I've got a document which will help you describe what the box plot means. What I don't like about the Desmos box plot is it's quite short, so you might need to find a better tool. Now, this box plot is absolutely fine in the fact that it's got no outliers, it's quite evenly balanced. I can see that visually, but in the exam you've got to prove whether something's got an outlier. We go into calc, and then we press one variable statistic, and this time we're going to have a look at list 2. List 2 is going to be second 2 for list 2, and then we're going to have a look. This time we've got different numbers. We've got 2, 3, 5, 7, 64. 2, 3, 5, 7, 64. I'm going to go back to Desmos. 2, 3, 5, 7, 64. Can someone put their hand up and tell me what they notice is strange about this box plot? Yeah, absolutely. This outlier is really obvious, but now in your actual IA, you can't assume that's an outlier. You have to use a formula to prove it's an outlier. And we learnt 2 formulas to show it was an outlier. And these are going to be the following formulas. The first formula we learnt about was quartile 1 minus 1.5 the interquartile range, and then the other formula is quartile 3 plus 1.5 the interquartile range. We're then going to make these bigger. And luckily, in my experiment, I have got a really clear outlier, and I'm going to apply that to the second screen. So let's have a look at this screen here. So if we go back to Excel, we're then going to substitute into these formulas. Quartile 1 and quartile 3. Quartile 1 is 3. We're going to just type in equals 3 minus 1.5 times is a star. The interquartile range is going to be the difference between quartile 3 and quartile 1. 7 minus 3 is 4. So we're going to say that anything less than minus 3 is going to be an outlier. Anything less than minus 3 is an outlier. We're going to repeat the process, but for now to the up down outlier. So this time we're going to start with quartile 3, 7. We're going to plus 1.5 times 4. Anything above 13 is an outlier. So looking at our list again, going back to sheet 1, if anything between minus 3 and 13 is an outlier, what out of these numbers is an outlier on the Y list? Anything which is not between minus 3 and 13. Jackson, which number isn't between minus 3 and 13? 64. So I'm going to talk about the fact that in my IA, I believe that this result is an outlier, and I might talk about the reasons why it's an outlier. And what I'll say is what I'm going to do now is I'm going to repeat the process but without the outlier. So I've copied and pasted the list of numbers, but this time I'm doing it without the 64 coordinates. And now we can see Pearson has become this number. Pearson is now 0.9409, and Pearson originally was 0.57 in the. What do you notice about Pearson now? 0.94 comparatively to 0.57. It's closer to 1. So it's a better positive correlation. So the person who got the best mark in the IA last year and he got a 15 I'd like you to have a think about, which is quite useful, and this is the formula. So the formula is really interesting. So for example, we've created the intercept and the slope. The intercept is where the trend line crosses the graph, and the slope is the steepness of the graph. Now, combining these together, either using a calculator or Excel, you're going to get a formula. Y equals minus 7.14563 plus 3.9443. Let's say this is predicting the BMI given the fat level. This is going to be really random, but let's say, for example, the fat level is 100. I'm just going to pick something really random. What we do is we take this formula and we're going to substitute x for 100, and that would then generate what y would be. So you could do a specific case of guessing what kind of y you're going to get for an x. So you can say, using this trend line, I can specify what I think y should be. But then you could talk about the disadvantage with your trend line. For example, you could say this doesn't work for all x values. For example, if you worked for an x value of 1, let's say if we had this, and we took this and we substituted in this time, like we do in the starters, 1 in for x, that's going to generate a negative answer. That would generate a negative answer of 4. So we can say you can't have a negative BMI. So you can talk about the limitations of the formula, because it's not going to work for all x and for all y. And just because your line looks like a straight line, perhaps a straight line doesn't best fit it. Perhaps an exponential curve fits it better. So another thing you could do is, let's change our lists this time. And with our lists this time, we are going to change them so they're a bit different. Let's change them so they look like they're not a straight line. So the way I'm going to do this is I'm going to clear the lists, and I'm going to put list 1, comma, list 2. Then we're going to go on to stat. Then we're going to edit, and this time I'm going to just say my list 1 is 1, 2, 3, 4, 5, and my list 2 is going to be something a little bit different. Let's call my list 2, 4, 8, 16, 32. You can see now this is not a linear straight line. It forms more of a geometric sequence pattern. Therefore, when we do the graph, we're not going to expect a straight line. So to analyse this kind of graph, you're going to go onto Calc, and you're going to go down, and you're going to look for something called power regression, and that's going to tell you what kind of model would best fit your graph. So if you click power regression, and you're going to say the x list is list 1, and your y list is list 2, and you're going to click calculate, it will show you that the model that best fits this, which gives you a really high value of Pearson's, is going to be an exponential model where you've got y equals 1.6 times x to the power of 1.67, and you need to check your power regression and see whether the power regression has the highest Pearson's, or whether your ax plus b has the highest Pearson's. You can see for this one, the Pearson's is 0.93. So a straight line doesn't fit this model as well as an exponential model. Finally, with this IA, you need to explain what all of this means. If you do this lovely maths, you might only get 11 out of 20. You've got to explain in English how this affects what your findings are. So if you're doing a subject you're passionate about, you can really talk about what you found out about it. So has anyone got any